Alright, so in this section we are using some laws to calculate limit of the functions or to find limit of the functions. So some laws. First we shall introduce, there are five main laws. They are basically defined on the operations on the function. So addition of function, if two functions are given in form of, if let's say a composite function is given in form of sum of two functions, then how we can compute the limit of those two functions? For example, f of x plus g of x, then limit basically distributes over this addition. Similarly, limit distributes over this subtraction. And if function is scalar multiplied or scaled with some constant, then a scale can be taken out of the application of the limit or the calculation of the limit, right? And in product form, if you compute the separate limit of the both functions and then multiply those limits, for example, limit of f of x is L, limit of g of x is M. Of course, when a approaches to the same number a, then limit of f of x and g of x is basically L times M. So this is limit of L, f of x, and this is limit of g of x. So this is L times M. And the same rule applies in the quotient or in the division of the function, with a restriction that the limit of g of x, the function in denominator, should not be equal to 0, or the function should not be approaching to 0 when x approaches to a. So this is important condition. We need to remember this one. And now we are using all these five laws to sort out some examples, or to simply simple some examples. This is explanation in words. I'm very sure you can understand it easily. Just go through this one. And now this is example one. First you have to look at the graph, right? Now f of x is a function, this, and g of x is a function with blue line. So purple line is f of x. This blue line, which is a discrete function, which is defined by these light blue lines. Now use the limit laws and the graph of the function. So function is given in form of geometry, or in graphically, or in graphs. In figure this to evaluate following limits. So first of all, limit f of x plus 5g of x, right? So what you will do, you will just distribute, first of all you will just distribute this limit x approaches to -2 for this function, then plus 5 is scaled, can be taken out of this limit operation and limit of this function. So remember this section 1, we are going to solve this first, and then B, and then C. So part 1 solution. So this is part 1. So from the graph, the limit x approaches to -2, then f of x approaches to 1. Now x approaches to -2. So this is 1, and this is 2 on the negative side. So when x approaches to -2, f of x approaches to 1. Now, well, this is limit, right? The value of function is 2, but the limit is 1, right? So this is equal to 1, and remember the value is 2. Value like f of -2 is equal to +2, but limit is 1. So it's written here, limit is 1. And next there is limit of g of x when x approaches to -2. Now look at this g of x approaches to -2, then g is -1. If you notice this one, so what is value of g here? It's a -1. So this is -1. Now we have 5 as a scaled, let's say parameter, scaling parameter for g. So our g is scaled with 5. So we can take this out like this: limit for f of x, limit for g of x, and this quantity is equal to 1, and this quantity is equal to, okay, it's -1 multiplied by 5. So in summary, or in short, it will be -4. So that's not I mean, too much difficult. What precisely we have used, so we have used limit law of addition here, limit law of scalar multiplication here, because we have taken 5 out of the limit, because we know from laws or rules that 5 can be taken out, so it's just very simple. So part B, now this example, product of f of x and g of x when x approaches to 1. Now x is approaching to 1, so we have to, let's say, keep in mind what is the limit of f of x, what is limit of g of x when x approaches to 1. So x approaches to 1 is this one, and here the value of f is 2, like this, and value of g is this one, -2, and we multiply these and we get -4. So look at this part B, limit of oh sorry, yeah, there is some tricky thing. uh, so value of f, sorry, limit of f, let me repeat it. So limit of f when x approaches to 1 is 2, because the left hand side limit and the right hand side limit both approaching to 2. But now this is value, this is not limit. Okay, this is value 2. So limit when x approaches to 1, g of x approaches to -1 from the left of the a, sorry, right of the a, right of the a, and from left of the a is 1 here, so from left of the 1 function approaches to -2. Now there is a, I mean, two different limits from left and from right, sorry, this one, from, this is from left and this is from right. So this notation positive tells us, and this notation negative tells us there's two different limits. So we see that f of x is, limit of f of x is 2 when x approaches to 1, that is settled, but does not exist because left and right hand side limits are different. So we cannot use the law for this product form because this g does not exist. But we yeah, so in summary, this negative and positive doesn't exist, so we can say that limit does not exist. So for part B, the precise answer or the short answer will be limit doesn't exist. After this analysis, limit does not exist. And now look at this part C of the example, the division. When x approaches to 2, like this value, x is here 2 and g approaches to 0, from this side, also from this side. Similarly, with same is the case with f of x, and it approaches to 1.5 from left and either from right side. So g of x 0, f of x 1.5, 1.4 or precisely maybe. Yeah, because of this scaling, I'm okay. So 1.4 and 0, and since g of x is 0, again it is in the quotient. Look at this one. So g of x is in denominator. So limit does not exist because the limit of the denominator approaches to 0, and yeah, limit does not exist. We cannot use law in simple. The limit does not exist. Okay. There is another law. So I hope it is clear. If you have any question, I will be waiting for your questions on the forum. So using a forum is very appreciated. So I will, let's say, notice that which students are participating on the forum. So yeah. So power law is when function is in some power. So there are some power on the function, and then simply you can evaluate the limit of the function and then power. It's as simple, right? So this is power law, power rule, or power law for the limits. And for constant function, there is no behavior of constant function. It's not going to anywhere. It gives you constant value, 1 point from left of any point, from right of any point, or whatsoever. So it's simply constant function. And linear polynomial term x approaches to the same value either from left, either from right. So this is simple. I don't need to, I mean, explain it more. I think it's more clear to you. Okay. This is same using this one 8 and 6, so we get this one. Using 8 and 6 we get this. Also, uh, so x, if you use power, let's say 1 over n, then yeah, it's also same. But it should be positive, because otherwise this limit or value will be in the complex domain, and we are not dealing with complex domains in this calculus class. Okay, so this is root law again. More generally, if it is simple x, then it is true for even any f of x. So if function is given in square root or in any root, you just take the limit of function and then take a square root. It's all right, with the same condition that f of x limit should be positive. If it is negative, so the root might lead us to or push us to the complex domain. So yeah, that is not our domain, right? Okay. And for simple polynomial, if f of x is polynomial, you just plug in. So the limits of the polynomials, I think I already mentioned this point already. Okay, if you have any polynomial and you want to find limit of that polynomials functions have very, I mean, normal behavior. They are like increasing or decreasing. So they do not have discontinuities. Remember. So this is the thing, right? Now f of x and g of x when x is not equal to 0, provided this is important. You need to, I mean, uh, remember this one. If functions are equal, right, and then their limits are equal. So functions can be equal for every parameter if basically they are same, yeah, or they are constant. So yeah, it's simple. Okay, so now this is again definition. Function limit of the function exists when the both left and right hand side limits exist and both are equal. Now this is left hand side and this is right hand side, and that both should be same L. If the both are different, so we say that function's limit doesn't exist, because from left it is going to some other value, from right it's going to some other value, and there is no common converging point, or the point where it is reaching, function is reaching. Okay, all right. So yeah, so this is another, I mean, rule or the theorem. When function is negative, oh sorry, less than another function, then its limit will be, so as I already told you, limit is about checking behavior of the function. So if function is, let's say, a function attains or gives you less, so this is f of x and values less than this is g of x, right? So f of x is below the g of x on the xy plane. So limit is also on this, in limit is also less than this one. So I think it's clear for you. And this is called a sandwich theorem or squeezing theorem. If we have three functions in this form, and limit of f of x and h of x at particular point a is same L, then the function in between will also have same limit. Now this theorem is mostly used to evaluate limit of the complicated functions. When, let's say, g of x is complicated, but we can establish that this function is less than this some simple hx function, and it is greater than simple fx function, and we know limits of these two functions, but we cannot find limit of this one. So we can just say that limit of g of x is same as of f of x and h of x. Yeah, examples will clarify this theorem. This is called also sandwich theorem. Remember this one, and this is an important one. Okay, this is explained again graphically, this sandwich theorem. Okay. I leave it for you, and even the proof is left as an assignment. I will put on the LMS, so you have to go through LMS. Stay tuned on that one. But certainly we are going to use this theorem in examples. I will explain the examples in coming slides. Thank you very much.